Okay, this is the last section that's in chapter 6 that we're going to cover from that chapter. Um, this goes back to work with solving equations, and it's going to be like what we had to do at the very beginning when we had a fraction in our problem, and we had to try and get rid of the denominators. So there's a couple things that we have to start out with and remember that a denominator can never be a zero. Alright, so after we solve the problem, we have to go back and check and make sure that our answer is going to work. So when we do this, we have to consider the values that can be used in a problem so that we don't end up with a zero in the denominator. Okay, this means we're finding what's called the domain of a function, and you should have already talked about that in college algebra when you talked about functions and you talked about range and domain. So domain just means of all the possible values, which are the ones that we could use, and which are the things that we would have to leave out. So to find the domain of a rational expression, you're going to set the denominator equal to 0, and then you're going to factor it and see if there's a number that would come out to make it be a 0. That would be the thing that cannot be part of your domain. That would be what we would have to leave off. So first thing you're going to do, our domain issues only concern the denominator, okay? So I'm going to look at my denominator and I'm going to see what the factors are. So here I have an x, factors of 21 that subtract to give me 4. So that would be a minus 7 and an x plus 3. Alright, we're going to set each one equal to 0. So x minus 7 equals 0. Add 7 to both sides. So if x is a 7, and I plug it in right there, 7 minus 7 is going to give me a 0. So that means my domain cannot equal, okay, so it's an equal sign with a slash in it. My domain cannot have a 7 in it. And over here then I'm going to say x plus 3 equals 0. Take the opposite, so x would be negative 3. So if I have a negative 3 and I stick it in my denominator, it's going to cause a 0 right here. So I can't have 7 or negative 3. Anytime there is a variable in the denominator, you have to figure out what the domain problems would be. So these would be two numbers that you would have to leave off. You could never get these two answers to be part of the answer for this problem. Okay? Over here it says find the domain. So there's some homework problems where all they're asking you to do is find out what would be the values. So my domain would be all the numbers, all real numbers, except anything that would cause this to be a 0. So if I factor this, I'm going to get x and then take out a x and then 4x plus 5. Set each one equal to 0. So this x by itself is just going to be x equals 0. We talked about that when we solved quadratic equations. A variable out here by itself, one of the answers is 0. And then we're going to solve this. So I'm going to subtract 5. So I'll get 4x equal negative 5 and divide by 4. So my two things that won't work would be 0 and negative 5 over 4. I can get any other answer, anything else in the world except those two numbers. Because if I hit either of those two numbers, when I plug it into my denominator, it's going to turn out to be a 0, and that can't happen. Now, when that happens on slope and the 0 is in the bottom, that's when we call the slope as being undefined. Here, we don't say it's undefined. We just say that those two values could not be possible answers for this problem. Okay? So a couple of your homework problems are just going to ask you to figure out what are the values that won't work for this problem. Now, let's go back and think about how we solved problems that had fractions in them. And you know you didn't just not work the problem. Okay? You have to know how to work them. So what we do? Find the lowest common denominator, and they're going to multiply it on both sides. And what did it do? It eliminated the fractions, okay? So I'm going to need to find what's the common denominator that 3 and 5 and 15 all go into. Well, the 3 and the 5 multiply together to be 15, so my common denominator would have to be 15. Alright, I'm going to multiply here by 15, and I'm going to multiply here by 15. So just reduce it out. 3 goes into 15 5 times. Okay, so the extra left over, the 5 would get multiplied to the 1, and the 3's are gone, so I just have 5x. 5 goes into 15 3 times. Multiply that 3 that you have times the 2 over here, and you'll get plus 6. Or multiply straight across, you'll get 15 times 2, which is 30, divide by 5, still going to give you a 6. Here, 15 times 1 would be 15, divide by 3, still going to get you a 5. And over here, the 15s are just going to divide off completely. So equals 11. Move the 6 over, so subtract 6, and you'll get 5x equals 5. And divide by 5, so x equals 1. Now, we don't have a domain issue here, because the 3 and the 5 and the 15, there's no x's next to them in the denominator. This x technically goes up to the top with the 1. So we don't have to worry about domain if there's no variable in the denominator. So here we have a lowest common denominator, but we don't have anything. Sometimes this is called, it's called the domain issues, and sometimes they just call it the restrictions. Okay, restrictions on this denominator right here means we can't get a 7 or a negative 3. Restrictions over here means we can't get a 0 or a negative 5/4. Okay, the things that you cannot be allowed to do is what that comes down to. All right, so I wrote a little step-by-step thing here. Okay, first thing, solving a rational equation involves factoring, because we got to find a common denominator, just like we did on 6.2 homework. Find the common denominator for all the numbers that would be in the denominators. So every place where there's a denominator, you're going to have to figure out what would that need to be. If there's a variable in the denominator, you may have numbers that will cause the denominator to be a 0. So that would be finding the restrictions, okay? It means it's going to have some limitations in this problem. Then we're going to do just like what we did here. Once we have our common denominator, we're going to multiply it on both sides. The factors that match up will cancel off, leaving the leftovers. Okay, so then we have to look and see, does our answer conflict with what can't be there? Alright, so on the first one, my common denominator, I have to have a y, so I'm going to put my y down there. For this one, it needs a 3 and a y. Well, I already have a y, but I don't have the 3 yet, so I'm going to put a 3 there. 6 is actually 2 times 3. I already have a 3, so I need another factor over here, so I need a factor of 2. So now that just means my common denominator is 3 times 2, so 6y will take care of all of those numbers. Now, I do have a variable in the bottom, so if I have a variable sitting by itself, just like we did up here, if we have a variable by itself, 0 is one of our numbers. So here 0 would be our only problem. Here if I plug in a 0, that would make that whole thing be 0. 6 doesn't have a variable over there, so there's nothing to do with that one. Only the places where there's a variable. And oh, that's a typo, that should be a y. Alright, so now our common denominator, we're going to multiply it on both sides. So over here I'm going to multiply by 6y. Over here I'm going to multiply by 6y. Alright, whichever one is missing, okay? The y's on this are going to cancel off. So the things that match, you're going to get rid of. Multiply what's left over. So get rid of the y's because they'll cancel, and you got a 6 times 2 would be 12. Okay, over here the y's will cancel. 3 can go into 6, so that would cancel the 3 out of the 6, leaving a factor of 2. So 2 times 8 would be plus 16. And over on the right hand side of the equal sign, the 6's are the same, so I can cancel out the 6's, and the 7 would just be multiplied times y. Now you'd have no denominators. So I can go ahead and work the problem out. This would be 28 equals 7y, and divide by 7. So y equals 4. Now I have to go back and I have to check with this is my restrictions. So is a 4 the same as a 0? No. So it doesn't conflict. There's no conflict here. So this answer is a good answer, okay? We're going to keep it. It's a good answer. It doesn't conflict. Okay? All right, let's look over here. These are all examples of problems that are going to be like in your homework. So here I need a 3x plus 5 for my common denominator. And over here I just have a single x by itself, and this single x, I only need one of them because it can take care of both. So now I'm going to look and see, okay, what would cause this to be equal to 0? Well, it's going to be a problem like this one right here. So notice what happened here. My 5 became negative, and then whatever's sticking next to the x gets divided. So that becomes negative 5/4. Alright, so what's going to happen here? This 5, if I make this 3x plus 5 equals 0, the 5 is going to become negative, and then I'm going to divide the 3. So negative 5/3 would not work for us. And if I have an x by itself, same thing over here, any variable that sits by itself, 0 would be the number that you couldn't do. Alright, so my common denominator, I'm multiplying everything on both sides. I'm just going to put one giant one. 3x plus 5 and an x. Okay, whatever matches cancels off. So you take what's left over, the 4 times the x, so that would be 4x. The x's match here, so the x's are going to cancel off, and I'm just going to have 1 times 3x plus 5. So that'll just be plus 3x plus 5. And then here, the x is going to cancel, so I'm going to multiply the 2 times what's left over. So that would equal 6x plus 10. Okay, combine like terms over here, so I have 7x plus 5 equals 6x plus 10. So you want to get your x's together. So I'm going to subtract the 6x, so 7x minus 6x. That's just going to give me x. And I'm going to move the 5 over with the 10. So that would be x equals 10 minus 5 is 5. Now make sure you move things opposite directions. So if the variables end up on the left, then the numbers have to move the other way. Don't be careless and move everything the same way. Alright, so now I'm going to look at my answer and see, is that a conflict with anything that I said could present a problem? No, so that's a good answer. Okay, so now here we only have one denominator. It's the same on both sides, so that has to be our common denominator, x plus 14. Then if we look at this and we set it equal to 0, x plus 14 equals 0, the opposite would be negative 14. So as long as we don't get negative 14 for our answer, we're good. Now I'm going to put parentheses around all of it. Everything, each piece has to get multiplied times x plus 14. Now that includes this minus 2 in the middle. Where there's a denominator, it's going to cancel off, and you're only going to keep the numerator. So when I multiply this times this, the x plus 14's cancel, and I just get x plus 28. But the 2 does not have a denominator, so it doesn't have anything to cancel, which means I have to multiply minus 2 times x plus 14. And then over here, the x plus 14's will cancel, giving me just 14. Now, distribute numbers. So I get x plus 28 minus 2x minus 28 equals 14. So my 28's will cancel, and that'll make negative x equals 14. And that means I just divide through by a negative, so x equals negative 14. Uh-oh, this time there is a problem, okay? So our question is, this and this is the same, and it says we can't get that for an answer. So when that happens, we just throw this answer out, and that means we have no solution. Okay, I starred this one because there is one like this on your homework, so make sure that you take a good look at that. Once you start doing these, most of the time students say that these are easier than other problems, because what you're basically doing is you just cancel off part of the common denominator that matches the part that's there. So let's look and see. Let's find our common denominator. Well, we need an x plus 6. And over here, if I take out an x, I'll get an x by itself and then an x plus 6. And this one's going to be the same thing. So the only thing is there's an extra x that has to be part of our denominator. So each of these will tell me what has to be over here. So take the opposite of this. So x cannot be negative 6. And I have x by itself here, so x cannot be 0. Alright, then I'm going to multiply x plus 6 times x. Okay, cancel off the things that match. So the x plus 6's are going to cancel off, and just multiply the leftovers to the top. So this will just be 5x. Here, we're going to cancel off what matches. It looks like it all matches, right? So that's just going to be minus 1. And over here, what's going to happen? Everything's going to cancel off, and we would just have equals 2. Are we good? Alright, add 1, so I get 5x equals 3, and divide by 5. So x equals 3/5. Question, is this a good answer? Is that good? Can we have 3/5? Yes. So this is a good answer. Alright. Over here, common denominator. It looks like we need each of these because we've got a 2 and an x. So I need a 2 and an x. Here I need an x, but I've already got it. Even though it's factor of 2 in front of it, x can be by itself. And then I need this polynomial, this binomial x plus 1. So each of these, this x and this x, will tell me what my domain issues are. So I have an x out here by itself, so 0 is one of them. It can't be 0. Use the opposite, so negative 1 won't work. Okay, then I'm going to put big parentheses, and I'm going to multiply both sides by that denominator. Cancel out the piece that matches. So the 2x's are going to cancel, and I'm going to multiply 1 times what's left over, which is just x plus 1. Okay, on the next one, I'm going to have a negative 3, and the x cancels off, but the 2 doesn't. So I'm going to have a 2 and an x plus 1 still. I'll just put double parentheses. And over here on the right hand side, the x plus 1's will cancel, and I have negative 5 times positive 2 would be negative 10x. Alright, so distribute this. That's a negative 3 times negative 2. So go ahead and multiply that. That would be negative 6 if I multiply it. And so I'm going to have x plus 1 Negative 6 times x would be negative 6x, and negative 6 times 1 would be negative 6, equals negative 10x. So let's see, this would be negative 5x minus 5 equals negative 10x. Add 5x to both sides. Since the x's are already over on the right, just move these over here. So that's plus 5x. So I get negative 5 equals negative 5x. And divide both sides by negative 5. So I get x equals 1. Is that correct? X equals 1. And this just says x can't be negative 1. So my answer is, as long as I've done it right, did I do it right? Yeah, minus 6. That looks right. So this answer is a good answer. Okay? Always go back and check what your domain issues have to be, because if this number matches any of these, then this number is not good. Okay, number 6. We're going to have one like these on your homework, so that's what I'm giving them. Now notice something about this. This happens a couple times. Both of these numbers will be the same way. If I put n plus 1 and n minus 6 together, I'm going to get this one in the middle. So I don't even need to factor it. N squared, it's going to end up being those two numbers right there. So they set it up basically like this for you. Alright, so now get my restrictions. Here x can't be, oh, this should be an n. I'm sorry, that should be an n. It can't be negative 1, and here it can't be positive 6. Alright, up here we're going to put our common denominator next to it, and we're going to cancel out the things that match. So this one cancels the n minus n plus 1s. I'm going to have 4 times the leftover, which would be n minus 6. On this one, it has all of those. So it cancels completely, and I just take the numerator, which would be plus 1. And then on this bottom one, it's got this n minus 6, but it doesn't have an n plus 1, so equals 1 times n plus 1 is just n plus 1. Okay, distribute, and I have 4n minus 24 plus 1 equals n plus 1. So this will be 4n minus 23 equals n plus 1. So I'm going to subtract the n's, get 3n, add 23 so that it ends up over here on the right. 1 and 23 would make 24, and divide by 3, so n equals 8. Is it a good answer? Well, compare it to this. Okay? It's not one of your restrictions, so it's a good answer. You always have to know what cannot be in your denominator. Alright, number 7 is the same way. If you put these two factors together, it's going to end up being the same thing that you've got here in the middle. So don't be scared when you get this. If you're not sure, just go ahead and FOIL these and say, oh, okay, that's what it's going to turn out to be. Now, here's another thing you have to be careful about. This minus sign is going to have to be distributed to those two numbers. Okay? Alright, our common denominator then is going to be 5x plus 3 and x plus 5. So, to get our restrictions, you're going to use the opposite of the 3, so that's going to be negative 3, and divide by the 5, so negative 3/5 will be one of them. And over here, the opposite is just negative 5. So, if you have a number in front of x, you're going to end up with a fraction here. You still do opposite for the 3, but then just divide the 5 and you'll get a fraction. Alright, so what cancels? Let's see, the 5x plus 3 is going to cancel off the first one. So 5x plus 3 cancels off, leaves me with a 3 times x plus 5. On on the second one, it has both of those. So the minus just needs to be distributed. So I'm going to make it minus 5x and then minus 3. So be careful about this one right here on the top. And then here equals, the x plus 5's are the same, so I'm going to multiply the 4 times the leftover, which would be 20x plus 12. Go back and distribute that 3, so 3x plus 15 minus 5x minus 3 equals 20x plus 12. I'm going to combine my x's, so I get negative 2x plus 12 equals 20x plus 12. Well, when I bring my 20 over, I'll have negative 20, so that'll be negative 22x, but I'm going to subtract the 12, so 12 minus 12 would be 0. If I divide by negative 22, I get x equals 0. Now, does this conflict with that? No. It's okay to get 0 as an answer. It just can't make the denominator number come from it. You just, if I stick a 0 in here, 5 times 0 is 0, but 0 plus 3 would be 3. So 0 by itself won't make that go to 0, nor will it make this go to 0. So 0 is a perfectly good answer in this case. Only when you have a single variable like here, or you have a single variable like right here, will that happen. Alright, last one. Single variable by itself. So do we have restrictions? Yes. So x cannot be 0. So my common denominator here would just be 6x. So I need one from each of them. A 6x, and 6x will take care of that one. Then I'm just going to multiply everything by 6x. Here, since it doesn't have a denominator that cancels anything out, you just multiply 9 times 6x. So that would be 54x. Here, the 6's and the x will cancel, so everything cancels, and it'd just be minus 3. And here the x's cancel, so you have 6 times 10, which would be 60. Alright, add 3 to both sides. So I get 54x equals 63, and divide by 54. And you have to reduce, okay? Reduce. Don't miss this, okay? Don't miss this problem. They can both divide by 9. So 63 divided by 9, divide by 9, you're going to get 7 over 6. This is your final answer. Alright, so this information, you've got to do your homework. You've got to look at this so that you know how to do it, because you're going to be doing this in college algebra. This is a skill that you need in college algebra, so make sure that you work on it. Alright, hope this helps. Bye.